All right, we're not going anywhere unless we discuss the 5 methods first. All right, because if we don't know the 5 methods and how to use them, today's going to be pretty rough. All right, let's see what we got. Any of the 5 methods of proving triangles congruent. Let's list them here first before I start these new proofs. Here we go. 15. Alexi, 1 method. Side angle side. Let's stop right there. What do I have to know about the angle in side angle side? If I want to use it, what do I need to know about the angle, Jonathan? In between the sides. Look, if it's not, just stop talking. All right, please stop talking. SSA is not a way. All right, that's the old. If the angle's not in between, you can't do it. All right, you cannot do it. Next method that you're aware of. 2, Bailey. HL, all right, good deal. HL, yep, hypotenuse leg. We discussed 2 days ago. Good. Only can happen in what type of triangle? Oh, let me ask that question. 22, Simon, what type of triangle can HL only be used in? A right triangle. So if it's not a right triangle, we only have 4 methods. All right, if it's not a right triangle, only 4 methods then. All right, give me another method. Oh, we already talked to me already, Bailey. Good. Cormac, another method. Angle side angle. What do you need to know about the side and angle side angle then? 16, Bryson, what do I need to know about the side? If I choose angle side angle, the side must be? In between the 2 angles. Yep. All right. New method. Another method, please. 7, Drew? Side, side, side. All 3 pairs of sides. And how about the final method that we have available to us if we want? Vinny? That's if the side is not in between the 2 angles. I can use angle, angle, side. Good. All right. There they are. Let's see what we got today. All right. Let's see what we got. Before you start writing any statements and reasons, can you take a look at the triangles I'm asking you to prove congruent? And because they overlap, highlight them with your colored pencils, please, so we can clearly see which 2 we're talking about, since they do overlap each other. And then you can write in your statements and reasons and mark your diagram. Just highlight them first. Let's look at the givens first. Can I use any of these as actual sides or angles? Take a look with me here, because this is what I know some of you still struggle with. TR congruent to TS. Everyone look at those, please. TR and TS. Are those sides in the triangles I'm trying to prove congruent? Are we all clear that they're not? Please ask now so I can go into further explanation. TR and TS are not sides in the triangles I'm looking for. So I'm not going to put an S next to it. We good on there? All right, how about the other pair? TM congruent to TN in the given. Are TM and TN sides in the triangles I'm trying to prove? No, they're not. So I'm not going to put an S next to those. So it looks like we have I don't want to say nothing, but I didn't start you off with anything. We need to find all three pairs together now. I provide the givens for you to use them. Okay? If you find yourself not using a given, something is going wrong. So why in the world did I give you TR equals TS or TM equals TN? What can I do with them to get an actual side in these triangles? Okay? Take a look. What can I do with these to get an actual? Because I gave it to you for a reason. Right? Just not to write it down and write the word given next to it. Use them. Use them. How can I use them? Bailey?
Subtraction.
Okay, what I'm going to do is I'm going to subtract TR and TM, and look what I get. A side in the triangle, don't I? And I'm going to subtract TS and TN, and what do I get? A side in the triangle. What's that subtraction statement going to look like? You guys are going to do all the work today. Henry, what's that subtraction statement going to look like?
TR minus TM
Equals?
is congruent to TS minus TM.
Okay. There it is, subtraction. I knew they were given for a reason. Immediately after subtraction, what's my next step going to be? 1, 2. Finley, what's my next step? And what's that substitution statement going to say after I'm subtracting those? What do I get? Yep. You got it. RM congruent to SN. And look what I can put next to that. You have your first pair of sides, everybody. First pair of sides. 1 down, 2 to go. 1 pair down, 2 more pair to go. All right, look at the diagram. Let's keep searching. Is there anything else we can see here? And this is kind of why I had you highlight them. To see maybe you would see this on your own by highlighting them. There's got to be something else out there. There's 2 more pair I need your help with. Cormac, what else?
I said angle R equals angle S.
Okay, I need you to be more. I know what you're talking about, but I need you to be more specific because there's actually a couple angle R's you could be talking about.
Angle TRS is congruent to angle TSR.
Okay, everyone, let's take a step back and understand where he got that from. What type of triangle is TRS? For test, what type of triangle is TRS? What do you know about TR and TS? What do you know about these sides? So what type of triangle is it? Isosceles. What did we learn yesterday? What's across from congruent sides? And take a look, everybody. What's across from TS? This angle right here, which is in one of the overlapping triangles. What angle is across from TR? This angle right here, which is in the other overlapping triangle. Does everyone see where those angles are coming from? Look for isosceles triangles today. That's what all these proofs involve, isosceles triangles. So here we go. Angle, again, you heard me talk to Cormac here. Don't call it angle R. There's a couple angle R's there. TRS, congruent to angle TSR. And we wrote this, I think, 3 times yesterday down as reasons. In A, how do we start this phrase? In A, triangle. And then I'm going to have somebody finish it. What's true in a triangle here? Look back if we need to. We'll remember it going forward because you're going to use it a lot today. Micaiah, finish it off for me. In a triangle. Good. Congruent angles are across from congruent sides. And again, I don't care if you switch the sides and angles part of it, but you got to have in a triangle. All right, so now we have a pair of angles. We're working our way there slowly. We're getting there. That means there's got to be one more pair somewhere. Search for it. Search for it. And again, listen, let me give you a piece of advice here. Don't look blankly at the diagram. You've highlighted the triangles, right? Look at all their sides and angles and see if you see anything here. Okay, look at the sides and the angles. Don't just look at any part of it. Look at the two triangles you've highlighted and look at the sides and the angles here. What do you got, Zoe?
RS equals to RS because of reflective.
Does everyone see you highlighted RS both times, right? And it's a side, isn't it? In both? Full side. Full side. Yes, it is. So RS, congruent to itself. Reflexive. And there's a side. So you guys have found all three pairs now. Subtraction, the fact that it was isosceles and a reflexive pair. So now the triangles are congruent. Now we just got to figure out, we wrote why. I definitely know it's not HL. It's not even a right triangle. So it's down to those four now. If it helps you out, we talked earlier in the week. If it helps you out, take one of the triangles and draw it out. I just drew out our MRS. Mark what you've marked on it. Let's see, I've marked that reflexive side. Let's see, we know MR is congruent, and we marked angle R there. So what's my method here? I'm going to write down for the two triangles being congruent. Finish it off, Stellan. Side, angle, side. That's where we are now. Okay, with these triangle proofs. Okay, that's where we are. Getting a little tougher to find the sides or angles. Any questions from you guys before we move on? Okay, let's move on. Right away, if you guys look at those two triangles, AEC and DEB, they're not separated, are they? They overlap each other, so you might want to see them by highlighting them. Even if they are separated and you just want to go to town and have beautiful colors on that, go right ahead. And then you guys can put the statements, mark your diagram, and let's see what we got. Okay, let's talk. All right, because it might get confusing here on one of the givens. AE congruent to ED. Can I count that as a pair of sides in both the triangles that you highlighted? Are those full sides in the triangles I'm looking to prove congruent? Are they? Everyone agree? Do I need to explain why they are? Because I'm going to put an S next to it now. I can count that as a pair of sides. Here's might be one that's confusing. Can I count AB and CB as sides? Remember, when I say, can I count them? They have to be full sides. They can't be part of a full side. Is AB a full side? No, it's not, right? AB is not the full side. It's AC. So I am not going to put an S next to that. So how many pair are we looking for now? Two more pair. Okay, we have two more pair on our own. All right, I'll open it up to you guys. Where can I find another pair of something here? Either get me a full side or an angle somewhere, maybe. Bryson, what do you got?
BC is equal to BC.
Okay, all right. Oh, now, okay. But I'm not going to count that as a side, though. Everyone agree? BC is not a full side, but I'm going to use it to get a full side. All right, so I am going to write BC congruent to BC, but I'm not putting an S next to it because it's not a side, a full side. But anybody want to take off where Bryson left, and how's it going to get a full side, Zoli?
Because AB plus BC equals CD plus BC.
I'm going to use it in addition. Great job, everyone. Great job. I'm going to use it in addition. So AB plus BC equals CD plus BC. Good work, everyone. Way to work as a group here. Addition. And now what's going to come after my addition step here? Vinny, what comes after my addition here?
Substitution.
To say what's true.
AC is compared to BD.
There you go. Now I have a full side. Good work, guys. Good work, everybody. Okay, but I still got one more pair to go, though, right? One more pair. And remember what we've been working on here the last 24 hours. Look at triangle AED, everyone. Look at the huge one on the outside, AED. Tell me something about that triangle that you know is true. AED, and look what you marked. Triangle AED, the big one. AED. One. Jonathan, what you know anything about that triangle? What is it?
AE and ED sides are congruent.
Which makes it what type of triangle?
Isosceles.
Okay, so if you tell me a triangle is isosceles, that means the sides and...
Angles are
Okay, so can you locate those angles that are directly across from those sides? And?
D.
A and D. Everyone see them? Take a look. Look across. That's angle A. Look across. That's angle D. They have to be congruent. All good. And you have to look in the same triangle the sides are in. So, step 5. Angle A. And again, I can call this angle A because there is only one angle A. Same thing with angle D. All right, what's that reason we've been writing down? 1/8. Lily, what's the reason? How's it start?
In a triangle,
Yep.
congruent sides are across from congruent angles.
Good job. And that's enough now. That's enough to say the triangles are congruent. And what's the method here? Again, we know it's not HL, right? So now we're down to 4. Jared, what's your reason here? Side angle side. Look for isosceles triangles. Anything? I know you have 2 more in your notes, but I'm only going to do 1 more. And then you're going to start the assignment because I need you guys to practice on your own or with each other. Okay, everyone, well, before we start writing and marking, look at the proof statement. A little bit different. I'm not proving triangles congruent anymore. I'm asking you to why ABC is isosceles. What makes a triangle isosceles? Let's start there first. What makes a triangle isosceles? Stephanie, what makes a triangle isosceles? 2 angles or sides. I don't need to do both. I just need to show one or the other. So in this diagram, Name two sides or two angles that, if they were congruent, would make the triangle isosceles. 1, 8. Lily, name two angles or sides. If I knew they were congruent, the triangle would be isosceles.
Angle 3.
Are those in the triangle, though?
Oh, no.
Right, I don't want those, because that wouldn't make the triangle isosceles.
Angle 1.
Okay, so A, if I knew angle 1 was congruent to angle 2, it would be isosceles. Or, what two sides? Lily, go ahead again. What two sides?
A, B, and AC.
All right, so if I can show either one of these is true, you got yourself an isosceles triangle. Okay, I don't need to show both. I don't need to show both, just one or the other. And I'm starting you off by saying 3 and 4 are congruent. And remember what we need: 1 congruent to 2, or AB congruent to AC, but not both. All right, it's been a while. All right, it's been a while. 3 congruent to 4. How can I get the ones next to them congruent? 1 and 2, right? It's been a while. Dylan, what's your thought?
Use supplements of congruent angles.
That's what we're going to eventually use. 1 and 3. Look at them. Look at them. 1 and 3. What do you know about them? Tell me their relationship. Come on, we're at this point in the year. 6. Alyssa, what do we know about 1 and 3?
They both equal 80.
Yep. And 2 and 4? Also supplementary. Everyone agrees? So that's the first thing we're going to write down before we write down that they're congruent. 1 and 3 are supplementary. And 2 and 4 are supplementary. A nice reason that we've used in the past, please. How I know they're supplementary. I don't want they form a straight line. That is true, but there's something better I can write. That used to be up on the board over here in Unit 2. How do I know those pairs are supplementary? 5. Jared, how do I know? Remember the reason? What do I call 1 and 3? I know they're supplementary, but they're also what if they're right next to each other and they form a line?
Linear pairs.
Linear pairs are? There we go. Good job. And then my final question, all right, 1 and 2. Angles 1 and 2, are they supplementary to the same angle? Look at it. Just don't shake your head yes or no without thinking about it. Are 1 and 2 supplementary to the same angle? No, but they are supplementary to 2 angles that are, what do we know about 3 and 4? Congruent. That's why we're going to use that theorem. So we're going to say 1 congruent to 2. Supplements of, what did we decide on? Same angle or congruent angles? 1 and 2, what are they supplementary to? Same or congruent? Congruent. Supplements of congruent angles are congruent. We're not done though, right? All right, 1's congruent to 2. What do I know about the triangle? If 1's congruent to 2, this is what type of triangle now? We're going, Cheryl, what type of triangle is this? Okay, how many congruent angles? No, there you go, done. Isosceles. Triangle ABC is isosceles. I'll help you out with the reason, everybody. Why? In your own words, before I write down what I'm looking for here. How do I know that triangle is isosceles right now at this point in the proof? Look at what we have. Look at what we did. How do I know that triangle is isosceles? 2, Simon, how do I know that triangle is isosceles? It has what? 2 congruent angles, right? Everyone agrees? All right, so 2 congruent angles implies I have an isosceles triangle. If I had the sides instead for some reason, I'd substitute in the word sides for angles. You're going to start on the assignment. You're going to call me over real quick if you get stuck. Okay? You're not going to call me over to see if it's right or wrong because you can go on Classroom to find out that on the answer key. All right, but let's get working as much as we can. I'm skipping over that last proof and notes because I need you guys to practice right now. You can work with other people around you or go to another group and work.